Microsoft Kinect for Xbox 360 allows users to make commands using only gestures or voice. With its large range of audience, the release of gaming device was a huge uproar. But what is usually missed is how amazing this technology really is. So how does the Microsoft Kinect really work? Kinect contains new technology previously never used before. If you remember the game iToy in PlayStation 2, you would know that movement recognition is not a new concept. However, the large difference is that unlike iToy, Kinect is able to detect depth of an image and recognize its players. This means no calibration and faster recognition, so more accurate and less timely setting up is. Kinect's hardware components are made up of infrared emitter, infrared depth sensor, color sensor camera, tilt motor, and 4 microphones. The color camera is a primary camera that acts to perform facial recognition and to take pictures. It has a similar build to standard cell phone or laptop cameras. The tilt motor allows Kinect to adjust the height and the position of the camera automatically for different users. The depth sensor of Kinect is made by an Israeli company called PrimeSense. How this works is that infrared wave is emitted through the infrared emitter that essentially projects speckles or patterns made of dots all around the room. This is then projected back and read by the depth sensor, which creates a depth map. Infrared is a non-harmful wave that cannot be seen by human eyes but can be through night vision cameras. Sunlight washes out speckle patterns and therefore explains why Kinect can only work indoors. The speckles are spread in different patterns all around the room to allow the depth sensor to detect the calculated area. So no area of pattern is equal to another. The depth sensor recognizes the pattern projected through an infrared emitter and uses this to calculate the angles of light. Then simple trigonometry is performed to work out the depth or the distance of the object from the device. The 4 microphones allow Kinect to perform voice commands from anywhere in the room using beamforming software. The software measures the delay through each microphone to determine where each player is in the room, and also communicates with the depth sensor system to recognize which player is speaking. Therefore, background noises and unrelated voices are ignored. It has also been programmed to recognize many accents. Now this is where the software comes in. The software is needed for the gaming device to make sense of the images captured. This is done by machine language learning. Millions of people in different poses were captured, and the images were labeled with important body parts manually by programmers. This is compiled into a computer farm that created a probability and statistics about how humans move and what they look like. The software is now able to recognize human form and track 48 essential points in a 3D space. Using the infrared camera and depth sensor, it assigns body parts and wireframes with 48 points based on the statistics acquired from machine language learning. It assigns the most likely skeletal structure and creates an avatar. The basic skeletal structure and face recognition from the color camera allow Kinect to know its player so it can use previous frames to take an educated guess to where you are and therefore to detect your movements. The algorithm for Kinect allows pattern recognition of human body to be read by machine language learning. A type of classifier called a decision forest from a collection of decision trees were made. Each tree was trained on a set of features on depth images that were pre-labeled with the target body parts. The decision trees were modified until they gave the correct classification for a particular body part across the test set of images. When the infrared speckles are emitted, the classifier assigns a probability of speckle patterns being on each body part. The next stage of algorithm simply picks out areas of maximum probability for each body part type. So an area will be assigned to the category leg if the leg classifier has a probability maximum in that area. Before, on devices such as the iToy, the user needed to calibrate, and then the device would use tracking algorithm to follow the calibrated point. However, on Kinect, the pattern recognition does all the work for you. It runs separately per frame so that it cannot lose track. Each frame is made in 2 milliseconds so it can detect each player's movements and also naturally recognizes multiplayers. So the 3D body joints determined in the algorithm follow the users in real time. So that is essentially how the Kinect works.